Let us do the following example to practice on this idea. A disk is spinning about its horizontal axis with a constant angular velocity omega s equals to 3 radian per second, which the horizontal platform on which the disk is mounted is rotating about the vertical axis at a constant rate of 1 radian per second. Determine the angular acceleration of the disk and the velocity and acceleration of point A on the disk when it is in the position shown. Okay. So it's similar to what we were talking about before, but we have numerical application here. Okay? So you have the following. You have a disk that is rotating about its own axis at a constant angular velocity of 3 radian per second. It's constant in magnitude. So you can say if omega s is constant, alpha s, which represents the change in magnitude, is equal to what? To 0, because it's constant in magnitude. But since omega s is changing in direction, when you derive omega s with respect to time, it will not be equal to 0. You will take into consideration the rotation of the axis of the disk. Why? Because here the disk is on a plate and the plate is rotating about Z. Okay? So the axis, if you want, will rotate about Z, and at the same time, the disk will rotate about Y. And we have that the plate is rotating at a constant rate, omega p, equal to 1 radian per second. If we look at the figure, if we do the right-hand rule, omega p is along negative z. So omega p vector is equal to minus k. While if you consider omega s vector, if we take the right-hand rule, it's along positive j. So omega s is plus 3j. Okay. Now the question first is to determine the angular acceleration of the disk. Whenever they tell you alpha and they don't mention anything, it's the absolute value. Yani alpha measured in a fixed frame, big X, big Y, big Z. Okay. So we have first, okay, we said that to be able to find alpha, we should go back to the definition. Okay. First, we know that alpha is derivative of omega with respect to time. Okay. Omega total with respect to time. And here, since we have rotation, the total rotation is due to combined rotation about two axes. This means that the disk is rotating about this axis. And the plate is rotating about z-axis. So we can say that the total angular velocity will pass by O, okay, and will be directed along what we call the instantaneous axis of rotation. You remember in chapter 16 in general plane motion, we said that we can talk about in general plane motion, we can talk about an instantaneous center of rotation. And in 3D, we can talk about an instantaneous axis of rotation. Okay? And if we have here rolling without slipping, can you tell me what will be the direction of the instantaneous axis of rotation? Who can tell me? If I tell you I
كيف
have...
تقصدي رولينج without speaking؟ اذا انه شو اللي عم يبرم على شو؟ انه مش
Okay,
عنا شي ديسك على الارض.
okay. أنا إذا عندي مثلا ديسك على الأرض، أوكي، وهيدا الديسك عم يعمل rolling without slipping على الأرض، يعني فيني أقول ساعتها إنه الكونتاكت point of contact with the ground شو الفيلوسيتي لإله بتكون زيرو. اوكي، هلا هون it's not the case. ليه؟ لأنه
Zero
البليت
is rolling
is
without slipping.
هون البليت is rotating، يعني منا fixed. بس in case مثلا عندكم هيدا ديسك moving on a surface, it's rotating about its own axis، والاكسس تبعه عم يبرم، وكانت الارض fixed، ساعتها فيكم تقولوا انه الانستنتينيوس center of rotation لازم يمرق بهيدا الاكسس of rotation should pass by this point because it has a velocity of zero, and also should pass by the intersection of the two axes of rotation. ساعتها this will be the instantaneous axis of rotation. So we define in 3D sometimes إذا عندك if points of zero velocity are clear بكفي نعرف 2 points عندهم velocity zero to determine the axis the instantaneous axis of rotation. هلا here it's not the case لأنه the plate is rotating. Okay, so they told us that the plate is rotating at an angular velocity omega p. فما فينا هون نجيب يعني with this information ما فينا نجيب instantaneous axis of rotation. But in other problems, in case you have a point of zero, the point of zero velocity is known and is under rolling without slipping with the ground, ساعتها automatically the point of contact with the ground is on the instantaneous axis of rotation, and we'll do several problems on this after. Okay, but here what we need is to get the total omega. So we can say first that omega total is the summation of the two angular velocities omega s plus omega p, and both are known in direction and in magnitude. Okay, so all we have to do is to replace omega s by 3j and to replace omega p by minus k to find omega total. Okay, this is the first step. I found omega total. Now to find alpha total, which is the angular acceleration, I should say, so if I write first that omega is omega s plus omega p, alpha total, okay, will be equal to derivative of omega s with respect to time, okay, plus derivative of omega p with respect to time. And to be able to do these derivatives, okay, first we should know if this vector is changing in magnitude and direction. Let us look at omega p first. Omega p represents what? Omega p represents the rotation of the plate around z, okay? Is omega p changing in direction, or it will always be along z, big Z?
Always along that.
Always
It
along
doesn't
Z.
change.
يعني حتى if I look in the absolute frame, it will always be along this axis because the plate is doing rotation about fixed axis. And therefore I can say that omega p is not changing in direction. يعني كأنه رجعنا ل 2D motion. So if I want to derive omega p with respect to time, I just need to consider the change in magnitude. Do I have change in magnitude for omega p?
لا.
لا. They said
No,
that it's rotating at a constant rate. يعني what is the derivative of omega p with respect to time? It's zero here.
Zero.
لأنه it's not changing in magnitude and it's not changing in direction. Okay? طيب إذا أنا ما انتبهت لهالanalysis, if I want to use the general formula that I just learned now, what is this formula? This formula states that if I want to derive a vector in big X, big Y, big Z, and if I want to get the derivative as seen in the absolute frame, It's equal to the derivative seen in small x, small y, small z, plus omega vectorial A. If you want to apply it on omega p, okay? What is omega p is fixed in direction in both small x, small y, small z, and big Y, big X, big Z. Why? Because if you look at the figure, this axis, يعني small z will always be along this direction. And what is happening? Look, small x, small y, small z will rotate with the axis of the disk. But the axis of the disk is rotating in xy plane. يعني what will change in position is a small x, small y. يعني if the axis, for example, if the axis is here, this is a small y, this is a small x, and this is small z at position 1, okay? Now, if the axis will rotate, y-axis will follow it, يعني y will always be along the axis of rotation. So if my plate rotate a certain angle delta theta, y-axis will become in this position. X-axis will always be perpendicular to y in the horizontal plane, so it will change in position. But z-axis, which is perpendicular to xy plane, will remain in the same position. Yani for me, this direction is fixed in the absolute frame and is fixed in the rotating frame. That's why, okay, I can say that my vector is not changing in direction in small x, small y, small z, and in big X, big Y, big Z. So if I look at the variation of this vector in small x, small y, small z, it will only be due to the change in magnitude. So it's just equal to d omega p by dt as magnitude. Along which direction? We said that if a vector is fixed in direction, if omega is always along this direction, alpha also will be seen in the same direction. So alpha p in case it's not, in case I have a variable magnitude, alpha p will be along z because no change in direction for this factor. Okay, so d omega p by dt is alpha p, but alpha p here is 0 because it's we have the case of constant angular velocity, and as a vector is pointing along k, so it's alpha pk, but since constant magnitude, it will cancel out. Okay, now what should I add? What should I add to this? I should add the effect of change in direction. How we write the change in direction? We said omega vectorial A. Omega vectorial A. Here, what is omega? Omega represent what in this problem? He is a rotation of small x, small y, small z about z-axis. The angular velocity of rotation is omega p. Yani here big omega is omega p. And vector A also is omega p because I am deriving omega p with respect to time. So I have the change in direction will be omega p plus omega p vectorial omega p. And you know that omega p vectorial omega p is 0. So we deduce, okay, that the derivative of omega p with respect to time is 0. So if you do it using the formula, or if you do it using some interpretation, you will get that it's 0 because omega p is a vector fixed in magnitude and fixed in direction. So its derivative in the absolute frame, of course, will be 0. Okay? Now, we still have the second term. We still have to derive omega s. So we can say that alpha is, this term is 0. So we just have now to evaluate the derivative of omega s with respect to time. And as we said here we'll use the formula, okay? We'll say that this derivative can be seen as the derivative of omega s with respect to time as seen in small x, small y, small z. plus what is big omega? We said it's omega p. Vectorial A, what is vector A that we are deriving? It's omega s. So plus omega p vectorial omega s. Okay. Now, they said also here that the disk is rotating about its own axis at a constant angular rate. So when we sit on x, y, z, we just see the change in magnitude. We don't see the change in direction. And since the magnitude is constant, so the derivative of omega s of the magnitude of angular velocity in relative to this along this direction is 0 because the magnitude is constant. So this term will be 0. Okay, and so this one represents the change in magnitude. I will give you an example where it is not 0. If they tell you the disk is rotating about its own axis at an angular acceleration alpha s equal to 2 radian per second square, for example. Okay, so this represents the rotation about this axis, the angular acceleration about this axis. So when you say, I want to find the derivative of the magnitude of omega s with respect to time in small x, small y, small z, you will just see that always this acceleration is along j and its magnitude is 2. Okay, so you can say that the derivative of omega s with respect to time in small x, small y, small z is just equal to alpha s j. And since here, so if I give you alpha s2, you put 2j. But since here alpha s is 0 because the magnitude is constant, you replace it by 0, you get that this term is 0. Okay, and now for the change in direction, the change in direction is accounted by omega p vectorial omega s. So if you do omega p vectorial omega s, we said that omega p is along a negative k, so minus k, and omega s is along j, so vectorial 3j, and k vectorial j is minus I, and we have a minus. So we obtain that derivative of omega with respect to time is a 3I. And since, as we said, the derivative of omega p with respect to time is 0 because this vector is fixed in magnitude and in direction, we can deduce that the total acceleration in this problem is just 3I. Okay? Any question on this?
Doctor,
Yes.
how did we know that omega omega
Yeah.
مش omega شو كان اسمها هيدي مثل اوم هي omega p.
Okay. لأنه omega by definition is what? It is the rotation of the small frame x, y, z in the absolute frame big X, big Y, big Z. Okay? And your rotating frame is attached to what? To the axis of the disk. Okay? So it will rotate with the axis of the disk. And since the axis of the disk is rotating about Z at omega p, يعني شو هي البيج omega؟ يعني big omega actually is omega p. لأنه big omega by definition هي rotation about small x, small y, small z in big X, big Y, big Z. Okay?
Okay, thank you.
Other question on this problem?
دكتور
Yes?
يس
Yes, tell me.
دكتور كنت عم تقولي لجو قبل شوي انه لانه ومثل هالاكزامبل لانه one rotation is along j و the other is along minus k يعني حتكون بالاخر along I لانه perpendicular ل both directions
Yes.
بس how can you relate هيدا مع ال instantaneous axis of rotation؟
Okay. ما خص, it's not related. Okay, look. here we are talking about acceleration direction. Acceleration direction, okay, whenever you have change in if you have a vector changing only in magnitude and you derive it, الانgular acceleration او الديريفاتيف يعني بتكون collinear مع الفector. يعني if you derive omega p with respect to time and omega p is only changing in magnitude not in direction, alpha p will be collinear with it. Okay, but if omega is changing in direction, then alpha will be due to this effect of change in direction, alpha will be perpendicular to the plane formed by omega p and omega s. لأنه نحن we proved mathematically إنه change in direction هو big omega vectorial omega s، صح؟ and this انتوا بتعرفوا من الvectorial product when I do omega vectorial omega s the resultant vector should be perpendicular to both. يعني انت هون what is big omega here? It's omega p. So the change in direction will result in a vector acceleration that is perpendicular to both, to the plane formed by omega p and omega s. Okay? ولأنه البلين of omega p omega s هو الواي زد، الانgular acceleration due to change in direction component will be along I، لأنه هيدي along K وهيدي along J. So the vectorial product will be along I. هلا بالنسبة للinstantaneous instantaneous axis of rotation, what is the meaning of it? It means that currently يعني at this instant the object seems to rotate about this axis and all points of this axis will have a velocity of 0. Okay?
اوكي.
هلا we'll
هن
see
التو
how to
methods
use the
يلي انت
instantaneous axis of rotation in other problems. نعم.
دكتور انت هون التو ميثودز يلي عملتيهم هي بس انه فكره انه يا بنطبق الفورمولا يا انه بس انه نحن بنعرف انه الريزلت تبع الفيتاس هي اوميجا اس بلس اوميجا بي، بنعمل الديريفي وبنوصلهم بالفورمولا. يعني مثلا انه وي ديديوست انه اوميجا بي هي هيدا قصدي الاوميجا هي الدبليو بي يلي نحن بنعرفها.
أكيد أكيد.
يعني بس انه هن اثنيناتهم بيرجعوا لذات الفورمولا يعني بالنهايه.
يعني أنا ما أنت البيج أوميجا بدك بكل بروبلم تعرف شو هي represent the rotation of small x small y small z about big x big y big z. In this problem أنت وين حطيت small x small y small z؟ حطيته على axis of the cylinder. Okay, of the disk. يعني الأوميجا هي represent the rotation of this axis اللي هي أوميجا بي. أوكي؟ أنا ما عملت two methods بس
لو اخذوا
تفرجيك
هن هون
تفرجيك الديريفاتيف of omega p with respect to time. بس to derive omega s with respect to time, this is the only method here.
اوكي ديل. لو هن اخذوا هون الفريم بيج اكس بيج زد بيج واي مش ميرجد مع الاكس واي زد الصغار،
ما
كانت
بيأثر.
بتتغير شيء؟
لا ما بتتغير لأنه big X big Y ليك هلا أنت هي الفكرة إنه big X big Y big Z فيك تحطهم coincident بس تتسهل على حالك، بس it doesn't matter. يعني إذا أخذت مثلا big X بهاللوكيشن وبيج واي بهاللوكيشن شو حتفرق؟ ما حتفرق شيء. المهم هون انه سمول زد وبيج زد هن فيكست بوث. اوكي؟ وهن كولينير. بينما كيف ما اخذت بيج اكس
يس
بيج واي it doesn't matter. اوكي؟
اوكي ديل. ولو اخذته بعيد للفريم يعني مثل ما كنت عم تفسري لنا اياها قبل.
ما بيأثر. اوكي؟ بس انت ليك انه بدك تاخده انكلايند، ما لها معنى
اوكي
تاخده انكلايند، بتكون عم بتصعب على حالك السوليوشن. فيك تزيحه ما بيأثر بشيء.
ما لها.
If you move it you don't
اوكي
change
ديل.
anything. اوكي؟ ما هو fixed، هو
اوكي بس انه
الكونسبت انه it's fixed، مهم انه هو fixed.
هم انه هو فيكست والسمول اكس سمول واي سمول زد ما عم
عم
يبرم
يبرم
اكثر
about
هيك
مين؟
لانه
about the vertical axis. Yes.
عم يبرم اباوت الفيرتيكال اكسس. اوكي ديل ميرسي.
اوكي. Okay. They also asked in this problem, okay, to determine the velocity and the acceleration of point A on the disk when it is in the position shown. So here, okay, we want to determine what is the velocity and acceleration of A. To find the velocity and acceleration of A, we just have to apply relation between velocity of 2 points. Yani what is the point on this rigid body for which you know the velocity and acceleration? Can you tell me? في point كتير هين على هالبody. I know its velocity and acceleration. What is the point?
Oh,
لأنه O مش نحن قلنا أنا وياكم إنه if I have rotation about two axes السميشن تبعهم إجباري تكون rotation about an axis passing by O. لأنه هون لاحظوا السمول y والسمول z both pass by O. يعني omega total will also pass by O. This means that أكيد O is on the axis of rotation. And because O is on the axis of rotation, what is the velocity of O?
Zero.
Zero. Okay, the velocity of O is zero. So we can relate the velocity of A to the velocity of O and the acceleration of A to the acceleration of O. So VA and AO are equal to zero. Now, what is the relation that I can use? I can use the same relation مثل ما قلنا مثل chapter 16 اللي هي velocity of A is equal to velocity of O plus omega. بس انتبهوا أي omega بستعمل هون؟ omega of the rigid body, the total omega. يعني omega total اللي هي omega S plus omega P. Okay? Vectorial OA. So all I have to do here is to say, let omega total هلا we calculated it. OA vector, if you look at this figure, OA vector can be decomposed into two components. One along J, يعني it's plus 1J, and one along K, اللي هي plus 0.25K. So now I can say that I can vectorially determine the velocity of point A by applying the relation between O and A. So I can say that velocity هلا هن عاملين غير if you want عاملين غير method. هلا I will explain it for you. But if you do the method that we talked about, you will exactly get the same result. Let me do this method and then I will tell you what they did. Okay? بلا عملوا مثلنا. سوري فكرتهم عاملين غير شيء. اوكي لا they use the same method بس دغري حطوا هون انه the velocity يعني هي الجنرال form. اوكي VA is VO plus omega vectorial OA. RA is vector OA. Okay. VO is 0 because O is fixed. Now vector omega total is 3J minus K as we have calculated before. Vector RA is vector OA, which is J plus 0.25K. So if we do the expansion, we get V of A. Please pay attention for acceleration. You should say AO plus alpha vectorial OA. ما فينا نقول هون minus omega square OA because it's not, you don't have 2D motion. You don't have omega, your omega vector is changing in direction. So you cannot apply, please, hey, the minus omega square OA is wrong here because it's not 2D, okay? So don't do it, pay attention. You should do omega vectorial RA. And you should pay attention for order. Yani what I mean by this, you say the following. You have that omega vector. هلا هون it's vectorial, okay? Here you write omega vector. You should do this before, and you should do omega vectorial RA before, and then do the vectorial product. And here I do J vectorial J 0 j vectorial k plus I يعني plus 0.75 I. Now I have k vectorial j minus I, and I have a minus plus I, and k vectorial k is 0. So this is the result. Now I do 3j minus k vectorial, the vector that I found. Okay? And I do normal expansion, which is j vectorial I is minus k, يعني minus 3 times 0.75 k. J vectorial. Here also it's I. Okay, يعني you will have in total 1.75 I. And k vectorial I is j, and we have a minus, so minus 1.75 times j. Okay, and once you obtain this, you will add it with 3i vectorial j plus 0.25k. You will obtain your total vector. Okay.
دكتور فينا بليز ناخد بريك؟
ما نحن عم نوقف at 3. اوكي.
بس
إذا بدكم طب
كتير
يلا when this session okay when this session will end we'll stop a little bit. Okay.
Okay, thank you.
Well, so now when we talk about
Doctor, question.
Yes.
بس ال W
yes tell me.
ال W هي WS plus WP.
أكيد W هي total, so this is W total. Okay.
طب لو إذا كنا عم نجيب VA relative للبلاتفورم
فيكم
اللي عم
هيدي تاني
تضرب.
ميثود رفيق، هيدي تاني ميثود. So this is the first method to solve. فينا نقسم الموشن إذا بدكم. اوكي يعني بأي معنى؟ فينا نقول إنه if I go back to my figure I can say that first if you look at your disk, okay, the center of the disk is doing what? A rotation. وال A is rotating about the center of the disk. يعني فيني اكتب انه اذا بسمي هيدا البوينت C, okay, I can say انه I can calculate velocity of A as velocity of point C, which is the center of the disk, okay, plus velocity of A relative to C. You can do this. Okay, بيطلع لكم the same answer. Okay, يعني you can decompose the motion. The velocity of point C will give you the effect of rotation of the center about Z axis, لأنه instantaneous axis of rotation إذا بدكم is rotating because of the plate. So the center of the disk is doing rotation about a fixed axis. يعني إذا بدي أعمل calculation للvelocity of the center شو بتطلع؟ Who can tell me?
WP times radius.
Exactly, WP times radius. ولأنه إذا أنا بتطلع بالdirection إذا بعمل الرايت هاند رول أوكي هيدي الvelocity will be along which direction؟ هي perpendicular للراديوس ما هيك؟
minus
لأنه
K.
omega p is لأنه omega p is along negative k يعني هيك. Sorry, 1 second. If you want to annotate here what is happening, you have the following. You have the velocity should be perpendicular to the axis of rotation. So إذا قلنا عنا الأكسس of rotation along y. Okay. The velocity should be perpendicular to the axis of rotation and should be directed along positive I لأنه عنا الأوميغا is rotating in the direction shown here like this. In this way. Okay, this is omega. Yani V should be in positive I. And we can say that the velocity of the center can be written as omega p times what is the radius of rotation. He uses distance اللي هي 1 meter. So times 1 along I. And we should add to it, okay? We should add to it the relative velocity of A with respect to C. So A is doing what with respect to C? It's doing rotation, okay? يعني, and this rotation is counterclockwise along positive J. يعني I can say, I can replace VA will be perpendicular, VA relative to C will be perpendicular to this. إذا برسمها بغير color. So this is point C here. And A is, if you stand on small x, small y, small z, you will see relative to C only rotation of A, it's rotating about C. Okay. And because the direction is in along positive J, and the velocity will be like this, in this direction. Sorry, 1 second.
دكتور بوينت سي على أي أساس بس حطيتيها؟
Point C هي center of the disk. رفيق سألني إذا فينا نقسم الفيلوسيتي اوكي ل two components، يعني نعمل relative analysis. You can do it. يعني أنت فيك تقولي إنه أنا بدي أقسم الفيلوسيتي due to rotation about Z و due to rotation about Y. اوكي. يعني أنت إذا بتوقفي إذا بتطلعي بالcenter of the disk، شو عم يعمل الcenter of the disk؟ It's rotating about Z. بينما شو عم يعمل A relative to C؟ عم يعمل rotation about it. Okay.